Hello guys, and welcome to the second part of balancing chemical equations. In this part we're going to check how to balance some, let's say, harder examples of equations where we can have two products instead of one. So I'll give you this example. This is the example that we have. C3H8 plus O2 yields or gives or produces CO2 plus H2O. So this is a combustion reaction. Now, what's different in this reaction? You can notice that there's three types of atoms. You have carbon, you have hydrogen, and you have oxygen on both sides. Typically in this type of reactions, we have an order to stick with. Usually first we balance carbon, then we balance hydrogen, and we leave oxygen for last. Why? It makes it easier for us, since oxygen, as you can see, oxygen is found in two compounds in the products, not just one. So you have oxygen in this one, and you have oxygen in water. While on this side, you have oxygen only in O2. Okay, so let's get started with balancing. Let's check for carbon first. How many carbon atoms do I have here? I have 3. How many do I have here? I have 1. Okay, but we don't write it, so this one is here, but we don't show it. So what should I do? I should multiply this by 3. Can I put the 3 here? No, this is incorrect. You do not put subscripts, you cannot change them. You can change only the coefficients. So this is the part where you can change. So I'll put a 3 here. Why? For carbon, 3 times 1, 3. And here 3 times 1 here is 3. So they are balanced now. Next, hydrogen. How many hydrogens do I have here? I have 8. How many hydrogens do I have here? I have 2. So I should multiply by a number to give me 8. What's this number? It's 4. 4 times 2, it's 8. And here 8 times 1, it's 8. So they are equal in this case. So let's do, just to make sure, for carbon, 3 times 1, you have 3. And for carbon here, 3 times 1 also, you have 3. So they are balanced. Let's check for hydrogen. 1 times 8 or 8 times 1. So 8 times 1, it's 8. And in water, hydrogen, 4 times 2, which is 8. So here, carbon is balanced, hydrogen is balanced. Now, we're left with oxygen. Now comes the real problem. I have oxygen in these two compounds. So, look what I should do. I should start with the products here. Let's take a different color. So, in carbon dioxide, in CO2, since you changed the coefficient, so this is 3 now, this 3 belongs to the whole molecule, not just for carbon. So any atom you have here, you multiply it by the coefficient. So for CO2, let's check the oxygens. How many oxygens do you have? Okay, you have 2. What's the coefficient? 3. So here it's 2 multiplied by 3, which is 6 oxygens in CO2. Now, for this one, how many oxygens do you have here? 1. What's the coefficient? It's 4. So 1 multiplied by 4. It will give you 4 oxygens. Okay, so, but in both of them, they are products. So, I should add them. 6 plus 4, it will give me 10 oxygens. 10 oxygens. So this is on the product side. I'll go to the reactant side. How many oxygen atoms do I have here? I have 2. The coefficient is 1, so 2 times 1, it's 2. I have 2 oxygens. And on the product side, I have 10. How should I make them equal? I should multiply this 2 by a coefficient to give me equal number of oxygen atoms, which is 10. So again, here on this side you have 10 oxygen atoms, and here on this side, in the reactant side, I need to make them 10. The subscript is 2, so I should fix the coefficient. What's the number that I multiply by 2 to give me 10? Of course, it's 5. So I'll put here a 5. Let's check. 5 multiplied by 2, 10. Let's check oxygen on the product side. 3 multiplied by 2, 6. 4 multiplied by 1, 4. So here is 6, and here is 4. You add them because there is a plus between the two molecules. So the total is 10. Oxygen is balanced. Carbon. There's a 1 here. So 1 times 3, 3. 3 times 1, 3. Balanced. Hydrogen. Here you have 8. Here, 4 times 2, 8. So they are equal on both sides of the equation. And now you have a balanced chemical equation. So the coefficients are 1, 5, 3, and 4.